Hi, folks. Joseph Kursky here with you to talk about developing spatial thinking skills in education and society. Developing spatial thinking skills in education and in broader society. Spatial thinking has been receiving increased attention in the last several years, I would argue, in the past decade. One reason could be the rapid expansion of geotechnologies from the GIS community to the general public, including recreational GPS, in-car navigation devices, apps on phones, virtual globe, and GIS software. Another reason could be recognition that accelerating globalization means that we can no longer be complacent about increasing the amount of spatial thinking in the educational curriculum at all levels. We're also starting to realize that global issues such as biodiversity loss, urban sprawl, energy needs, water, quality and availability, natural hazards, human health, etc., are becoming increasingly complex and increasingly affecting our everyday lives. Moreover, they all have a spatial or geographic component. To grapple with these issues for the 21st century requires a populace that's adept and skilled at using GIS and other geotechnologies. Also, piquing people's interest in spatial thinking may be the National Research Council's 2005 report, still relevant today, called Learning to Think Spatially. Learning to Think Spatially. GIS as a support system in the K-12 curriculum, which recommends that spatial thinking be recognized as a fundamental part of primary and secondary education due to its importance as a problem-solving set of tools in many different disciplines. Rather than as a separate course, the report states that the USA, for example, needs a national initiative to integrate spatial thinking across the curriculum in courses such as mathematics, history, science, etc., and that the country needs standards to be developed that can be used in teacher training and student assessment. I would argue also that this report's recommendations transcend political boundaries, that it should be for all countries in the world, not just the USA. Now, all of this may be encouraging people to consider graphicacy equally as important as teaching numeracy and literacy. So graphicacy, spatial or visual thinking. There may be other equally valid reasons for the increased attention to spatial thinking and learning. Through Dr. Jerome Dobson's wonderful articles years ago in Arc News and elsewhere, Dr. Harm DeBlay's book, Why Geography Matters, and even through works by others outside the geography community, such as Thomas L. Friedman's The World is Flat book, the message is clear, folks. We ignore the world at our peril. Those who have taught with GIS for the past few decades have long advocated spatial thinking as the foundation, really, for success in problem solving with GIS. In fact, geographers and geography teachers have promoted spatial literacy and spatial thinking for, I would argue, centuries. Many welcome this new attention to spatial thinking and are hopeful for the future. Without spatial thinking, the complex issues facing our world cannot be effectively and completely dealt with, I would argue. Without spatial thinking, scale may be critical to a problem but ignored. Without spatial thinking, a person can be proficient in working with GIS software, but will likely have difficulty in thinking outside the software box, considering problems holistically and examining problems from a spatial perspective, whether they use GIS or other tools.